Assalamu alaikum everyone. Today I have a question under integration where it says that find the integrals of limits of 0 to 2 of 4x squared sin x dx. So previously I have in my previous video I talked about how to integrate a such function with product of two functions. So let me remember you about product rule in differentiation calculus. In differentiation calculus, wherever you find the product of two functions, you apply the product rule technique. But what of in integration? So in integration, whenever you find product of two functions, then the best technique to apply in that question is partial integration by parts. Integration by parts is the best technique to solve a function with the product of one or two to two and more functions. Then just apply an integration by parts. Now, but several students find difficulties on how to apply, and the integration by parts state that wherever you are given a function of v du or u dv, let's start with u because the one which comes first before v. So you assume one function to be u and one function to be dv, so that it can be the function of u times dv. But current in differentiation calculus, when you find those two functions, you just set the function to be u times v, the function of u times v. But in parts, we just say the function be u dv. Why? So when you integrate the function of u times dv, is just taking u times v. You just jump the d, u times v. The function strength equals u times v, which is uv. Then subtract v d, reverse now. Just the uv. Then when you want to write this one, just say then now integrate u dv, v du. So v multiplied by du. This is what integration by parts talks about. Now, but the problem is, what will you say to be u and what will you say to be dv, and why? And why? Why do you set one to be u and one to be v? So for you to set a function like sin x, just look, sin x. Will sin x, can you make sin x get lost when you integrate or differentiate? Will it keep on reducing and finally disappear? Sin x will never disappear. Sin x, and remember, what makes a function to disappear is differentiation. When you differentiate equation several times, it disappears. And in this technique, you should make one of that function disappear so that it can be so easy for you to differentiate. You select, so the function that you are going to differentiate, make sure that it will disappear. So when you select sin x to be this function that you are going to differentiate, it won't disappear. It will keep on changing from one state to other, but it will never disappear. But let's go to 4x squared, that function. Function of 4x squared, it will disappear when you differentiate it several times. It will disappear, obviously, because you minus 1 the power, but sin x, the derivative of sin x, cos x. and the derivative of cos x minus sin. So it will keep on changing one form to another, but it never disappear. So why do we talk about disappearing? Now let's come and apply that. Now, so you have to set u to be something and also the v to be something. This is interesting. When you understand that, then it is interesting now. Now, what to set now u and what to set v? So you set u what you are going to differentiate, because we need du. When you set u to be something any else, you can come to your function. We need du, and for dv we have to integrate because we need v. So since we need to differentiate and we have selected our function which is you have to differentiate is 4x, just write let u to be 4x squared, and hence also the other to be sin x. Now you have correctly selected which function to be u and which function to be dv. Now, what is du? So du is the derivative. Now we want du. Du is just the derivative of this function, which is that just 8 of x. And dv, we want v. We have to integrate this function. When you integrate sine, it then becomes minus cos of x. When you integrate sine, it changes the sign from what currently it was to the other form. So, and remember, when you integrate minus cos, it changes sign. So can't you see this is what you're supposed to know? When you differentiate cos, it changes to positive sign. When you integrate positive sign, it changes sign to negative cos. So this is the theory under which you have to know in trigonometric calculus. Now, let's now apply this to our question. So the integrals of 0 to 2 of u dv, it will be just u times v. U is this one, v is this one. So it will be just 4x squared multiplied by minus cos x. Then we minus the integral of u of v, which is minus cos x multiplied by du, which is 8x. Now, let's simplify that function. So the integral of 0 to 2 of u dv is equals to 4x, for minus, to be minus due to minus 4x squared cos x minus the integral of minus 8x cos of x. But you can see that still we have to differentiate this. Why were we saying that you have to select u to be the function that keeps on reducing? Trigonometric function never, like cos, sine, and tan, they will never reduce, but they change just from one form to another. But now we also need to integrate this function, because for we to bring this function to an end, the integration to an end, we have to eliminate, to keep one function reduced to 1. Then our integration, it will be at the end. Now, we need also the integral of this function. Now, let's find the integral of minus 8x cos of x. So minus 8x cos of x, we just select our u being minus 8x because it can reduce, and du, don't mind, just set it to be cos of x. Then du, it will be just, we differentiate. When we differentiate this times 1, it will be just minus 8. Then minus 1, it will be x raised to the power 0, which is 1. Now, can't you see that one function has disappeared now, and we are done with that function when we integrate this form. Now, the derivative of the integral of cos x is just a positive. When you integrate cos x, it just give you positive. Now, so cos doesn't change sign in integration, but changes sign in differentiation. So the owner, we can conclude and say that the owner of the integration is sign. Sine is the one who can change its sign when integrating. But cos, the owner of differentiation is cos. Why? We can say that so that for understanding and easy remembering what to do. So cos, the owner of cos is just that's what I used to say. The owner of differentiation is cos, because cos can change from one sign to another, but sine keeps on retaining its sign when you differentiate it. But now the owner of integration is sine. Now sine here is the same. So when you differentiate, this should be dv. When you differentiate dv, when you integrate dv, you get v. So we have to integrate for it to get v, and this one is not the owner of integration and just turn to sine x, but it will not affect the sign of that function. So let's now apply our the integration by parts, which says that the integrate because there's product of two, so the integration of this one of u dv is just we take u times v minus, then we just deduct or subtract v du du, but you have to take the integral of this now. Can't you see when you get, for it to let it come to an end, you just have to make one of function disappear, then you make it an end. Therefore the integral of u dv, this function, but remember what you are integrating now is this function, and you should not forget about this term. We have first term, this is the second term, but the technique needs us to further integrate the next term. So u dv is just uv, so u times v, which is minus 8x sine of x, then we will minus the integral of v du, v times du, which is minus 8 times that one, which is minus 8 sine of x. I think now we have brought this function to an end, because now the integral of minus 8 sine of x is not product of two functions. Now it has become one function, and that is what we meant by saying you have to select one function to bring it to make it disappear, so that you can differentiate only one function. So the derivative of sine we know is just minus cos. So minus cos now, and minus 8 multiplied by minus cos x. This is just a constant. So when you multiply, just minus and minus become positive 8 cos x, and we are done. So it's just write this function well. Write this function well with just minus 8x sine of x minus the integral of that is, which it become positive 8 cos of x. Now remember, we had a term before this, which is this one. The integral of this was this one, and also the integral of this here is this. Therefore just put it, substitute it where it was, then take this one back to the original function. So the integral of 0 to 2 of u dv you just you take 4x squared cos x to be 4x squared cos of x, then minus the function, this function, the integral of this function we have come to an end is this one here. Therefore minus bracket minus 8x sine x plus 8 cos of x. So the integral of this, so we conclude that is 4x squared cos x plus 8x sine x minus 8 cos of x. So you just have the limit from 0 to 2. So you just substitute the limit and obtain your answer. Just substitute x with 2, with 2, with 2, with 2, with 2, and you finally arrive to your answer. So substituting the values of x, then we'll substitute with 2 there, it will be 2 squared. So 2 squared is 4. So 4 times 4 is 16. So key in 16, then cos of x. And x, we know x is 2. So cos of 2. What is the result? The result is 15. 15 point, which 15.99, which is the same as 16. So let's say 16 plus 8 times 2, which is 16 also. 16, then 16 sine of, key in sine of 2, which give us 0.0558. Then minus 8 cos of x. So 8, then key in cos of x, which x is 2. The result just 7.995. So take the summation of that, which is just 16 plus 0.5584 minus 7.995. That is just 8.5634. So I think we are now done with the integrals of that function. So welcome to my channel. So, and as a reminder, don't forget to key in the subscription tab and activate the notification tab there, so that you can be updated on my videos as I keep on uploading. So I'll be posting more and more videos on integral calculus and other many videos under calculus and mathematical sets. So welcome to my channel. Feel free to just subscribe and like my video. Feel free to comment on what to improve, and let me know that you are interested and you are benefiting from this video. So welcome to my channel.